So the amazing Zazzle is about to be launched out of this cannon, and there are two important variables we have to understand. One is this variable t, that's how long it has been since she was launched from the cannon. So she starts her launch at time equals 0, and then she's going to fly through the air for a couple of seconds. And then the next variable that we need to know is h, and h is the height above the safety net that's going to catch her. Now, if I were Zazzle, that would be a pretty important variable to me. I'd want to know how high it was. And when we plot this on a graph, I want to draw your attention to the vertical axis, which is height, and the horizontal axis, which normally you would think of as the distance from the cannon, like how far out from the cannon you go. That's not it. This is time. And that can be confusing because if you think about her getting shot out of this cannon, you're going to think, oh, well, here's the cannon, right? And the poor lady gets shot out of it and she goes like flying over there. Yeah, that's what her trajectory will look like. But that is not what's being shown on this graph. The graph is just height versus time. So for all we know, I mean, this isn't really happening, she could get shot straight up in the air, like vertical. And then that would be fine according to this graph because all it's measuring is how long you're in the air for, not how far from the cannon you got shot. So with that out of the way, let's start talking about a few of the features on this graph in a little more detail. And the first thing I want to highlight is this right here. So that's a very important coordinate point because what it has in it is the height at time 0. So this is time equals 0, right? That's launch. She gets shot out of the cannon. And it's how high is she when she's launched. She starts her journey through the air at 39 feet high. Okay, and some versions of this question will ask you for that. That's not what this one's asking for. This one, if you look up here, is asking for the maximum height in feet. Okay, so remember, if height is the vertical axis, we're asking how high does she go? Well, you can see that one right here. Okay, that's her maximum height in feet. Okay, so we're going to say it like, so we're going to say max height equals 110.49 feet. They really measured this very carefully. And then we could say it's at time equals 2.1 seconds, right? So a little more than 2 seconds into the cannon flight, she's at the top of the arc and she's about to start coming down. Now that leads us to another part of this problem. Some versions of this question will ask you the following. They'll say, okay, well, when does she hit the net? Because that's kind of an important one. So if I were Zazzle, I would be interested in this one right here. Very, very interested in that because I want to make sure I'm hitting the net when I'm expecting to. And the way we do that is we say, okay, so we have over here we say time equals 4.72 seconds. And at that point, you have height equal to 0. In other words, she's been caught, hopefully, or she hit the ground, we don't know, but her height is definitely not in the air anymore. One way or another, this cannon shot is over.